Welcome to Presentation 31. Today's subject will be resistive touch screen. This is the first of two presentations on that subject. Now the touch screen is part of our layer 3 architecture. We are going to be using this time the from layer 2 the UART framework, the A to D analog to digital framework, and the IO port framework. Also, I would like to note that the items in green are presentations that I've already done. Yellow is what I'm going to be presenting today. And the one in items in gray are the ones that presentation. So let's get to the agenda. So today I'm going to talk about resistive touch screen. I'm going to give you a description. We're going to look at the schematics. We're going to go through a sample program, one which I've called the data collection, and then we'll have a second sample program. And finally, we'll end up with the summary. So let's talk about the description. So resistive touchscreen is built from two thin transparent layers. Here. Each layer has special coating that can carry electricity. Two layers are separated by a tiny spacer so they don't normally touch. So basically you have two transparent layers. They are conductive and they are separated by spacers, and they would go in top of a display, for example. So when you press on the screen, the top layer bends down and makes contact with the bottom layer. So this is kind of gives you an example. At the spot, the two layers become at that spot, I should say, the two layers become electrically connected. So now let's see how this works. First, the controller puts a small voltage across the bottom layer. So we put a voltage right here, and we have the ground. Next, the bottom layer has a smooth voltage ramp from left to right. So we put a voltage here, and all they're saying there's going to be if you look at the voltage, if you measure the voltage, you're going to see that it keeps increasing. And that's because your the coding that the screen has, the transparent screen, it has different, the resistivity changes to that coding as you move from left to right. So like they note here, the bottom layer has a smooth voltage ramp from left to right. Now when the top layer touches it, the top layer now picks up the exact voltage at that position. So basically, when you push the screen at a particular position, you're going to get a unique voltage. If you move to the right, you are going to get a different voltage. Now, by measuring that voltage, the controller knows how far across you touch. So as you move from left to right, the voltage is going to be changing. So you could figure out how far you've gone from left to right according to the voltage. Now the controller does the same thing with the other layer. That would be the top layer. This time putting a voltage on top to bottom. So now what you do here, you put a voltage, so you have a gradient as you go from top to bottom. Again, the touching point transfers that voltage to the other chip. So when you touch, you're going to transfer the voltage, and the voltage is going to be unique for each of the positions that you go from top to bottom. And measuring it tells the controller how far down you press. So you have unique voltage. So by knowing what voltage, you can figure out how far down you've gone. So you have two options on how this gets mechanized. First is the resistive touchscreen interfaces directly with the microcontroller. That means that the microcontroller has to provide for example, if we want to figure out what's the X position, the microcontroller has to provide the ground and the 5 volts, and it has to be able to read the analog signal, which is the voltage change as you change that. And it has to do also for the Y, to figure out what's the Y and what's the X. And so you would need to use your analog digital conversion channel 2 and channel 3, for example. Now, the other option, the second option that you have is resistive touchscreen interfaces via the XPT2046 chip with the microcontroller. Now, what you have here is a chip that's going to take care of applying what the controller has to do in this case, which is applying the voltage and the ground and reading the analog signal. And then once the chip gets that information, it sends it to the ATMEGA, to the microcontroller via the SPI bus. Now, this is option 1 we're going to do now, and then we'll do option 2 the next presentation. So this is kind of the schematics or what that we want to do. So what we're going to do is we want to be able to have a panel where we have an on and off button for a blue, green, and white LED. And when we press that buttons, we can turn on and off the LEDs. And then we are going to connect to the microcontroller X1, Y1, X2, and Y2. So we can provide the voltage and read the analog feedback. And then we're going to provide also a means to be able to provide the information to the laptop. So first we start with a blank touch screen. So this is your regular touch screen, and you have your 4 lines, X1, Y1, X2, Y2. So what we're going to do, what I did, I should say, is so I took a piece of paper like this, I cut it, and I pasted it behind the touch screen. So our task is going to be to figure out how we go about making this glass that has different resistance. No matter where I touch in this glass, I'm going to get a different voltage. And then what we're going to try to do is figure out exactly what is the voltage for when you press the on, off for the green, blue, green, and white. So that's going to be the main thing, how that works. Okay, so this is what we have to do basically. So how we get that done. So first thing we need to do is we need to enable the channel 2, analog to digital conversion, channel 2, channel 3. So now we're going to be able to use one channel at a time. So either we're going to use the channel 2, in which case we read the X2 by providing the 5 volts and ground, or we're going to enable, so then we disable this and we enable this to get the Y coordinates. So this enabling this channel, we know how to do that because we did it. I've already presented in my analog digital conversion presentation. Now, this is new, how to configure to read Y. So we want to read Y. So what we need to do is we need to configure the X1 and X2 to output, and then we want to read the analog signal that comes from Y2. So how do we do this? So we have the X1, as we said to read the X, what we do is we set the I'm sorry, you're confused. So I want to read the Y. So what I do is I set the X1 and X2 to output, and then I place a ground and 5 voltage output to those two signals, and then I set the Y1 and Y2 to inputs, so that's where I'm going to read my my analog. So to read the Y, set the X1 and X2 to output, place a ground and a 5 volts output, and then read the result from our channel 3 analog digital conversion. Now, if I want to read the X, what I do is I set the Y1 and Y2 to output, Then I have to place a ground and a 5 volts signals. And then I set my X1 and X2 to inputs, and that's where I read my analog signal. Actually, I'm just going to read it from X2, of course. I just set both to input convenience. Okay, so let's look at the sample program one. So we have a clear displays. I pasted this picture behind the screen. No matter where I touch in the screen, I get a voltage, different voltage. So what I'm going to do is I'm just going to press the button, my stylus. I'm just going to go back up and down through each of these squares. And I'm going to measure the output and I'm going to send it. And the idea, I want to get the boundary for each of these buttons. So let's see, let's look at the program statement. Capture the touch input. So of course we need to capture the input. Write code that continuously check if the screen is being touched. Next. Read the X and Y voltage value from the touch screen and forward them to the laptop. Read like I said, then forward to the laptop. Step 2, collect the data. Identify the regions of the screen from where you want to collect the data. Touch this region multiple times and record the X and Y values. This action will give you the boundary values for each area. So come here and just do exactly how I'm doing right now. Capture this data. Do it here. And that's the step 2. Step 3, define the boundaries. From the recorded data, determine the minimum and maximum X and Y values for each of the regions. So when we get the data, let's figure out what are the boundaries. Let's do the analysis. Now, at the end of the day, these values define the boundary for each of the buttons. So that's what we want to do at the end of the day. Figure out when you come and you press any time within this square, you get the blue light on. So let's So I'll start by giving you first a global view of the program, and then I will come back and we can go through some of the details. So we have here routine to initialize the analog to digital converter. Next, we're going to initialize the interrupts. Then these two routines enable the channel analog to digital conversion channel 2 and channel 3 as required. Then we have two routines, one to configure so we can read the Y parameter or the X parameter. And here we have the main program, which is functions, basically is to initialize whatever needs to be initialized. Next, we have here the interrupt service routine. The interrupt service routine, the main functions of the routine is going to be to collect the data, because this routine gets called every time the data is ready to be processed. Or I should say the data has been processed and we go and grab that data, and then this routine is going to send it to the laptop so later on we can analyze it. So let's start and get into some of the details. So what we have here is the X1, Y1, X2, and Y2 are going to be assigned to port C0, 1, 2, and 3. Now this routine, the init, the analog to digital conversion, that's something that we've seen in the past, so I don't want to spend any time here. The same scene goes for the initialize interrupt and enable channel 2 and channel 3 of the analog to digital conversion. All that information I've already provided in my presentation dealing with analog to digital conversion. So what we have here is the one routine that is going to configure so we can read the Y. So what it does, it sets the X1 and X2 to output, and then it assigns the output for X1 to be ground and for X2 to be the 5 volts, and then it sets the Y2 and Y1 to inputs, and that's where we're going to read the analog to digital conversion. Next, to set up the to read the X value, what we do is we set the Y1 and Y2 to output, and then we assign the values of ground and 5 volts to Y1 and Y2. And finally, what we do is we place an input. We place the X1 and X2 to wait for the input. Now, in the main program, we're going to initialize the analog to digital conversion. We're going to initialize the UART. The UART we need to initialize is because all the data that we get from here, we're going to send it to the laptop so we can analyze it. Then we have a hello world as usual. And to start, we configure to read the X value, and we enable the channel 2 and enable interrupts. So let's get into the interrupt service routine. So this routine was triggered. That means that there is data available. So we go and collect the data. And again, all this, we've already done it in the past. So the next thing we have is we have a switch. Depending with which channel we're getting the data from. If it comes from channel 2, that means that this is an X value. If we get from channel 3, that means that's a Y value. Now, if it's an X value, what we do is we assign the X, the conversion result, and then we send it to the laptop. Next, we configure so we can read the Y. We read the X, so now we're going to configure to read the Y, and we're going to enable the channel 3, which is the one that actually reads the Y value. Now, if the channel is 3, that means that this is a Y value, and again we assign the conversion result to this variable Y. We send it to the laptop, and then we configure so we can read the X value, and then we enable the channel 2 so we can get that value. And if we have a default, then we send something that says no channel was selected, or actually maybe say invalid channel. Then we put the channel number, and then we enable the interrupt again. So this is just, I don't think we'll ever get here, but if something happens that the value is not 2 or 3, then we can troubleshoot it. So that takes care of this program. So let me just back up. So we enable one of the 2 channel analog to digital channel depending on what we want to read, and then we configure to read X or Y. Then once we get an input, we send it to the laptop so we can analyze it. So okay, so we've done on sample program, we're done step 1, step 2. Now we need to go through a step 3, which is from the recorded data, determine the minimum and maximum X and Y values for each region. These values define the X boundary for each of the area. So what I did is I took and start going up and down through this, touching this button and getting the output. Next, I did the same thing for this button. Next, I went ahead and did the running the my pen through this value so I could collect the values when we are within this area, and I did the same thing for the green, and finally I did it for the white button on and off. So let's see the data. So I took the data from the laptop and copy and paste into Excel, and then I graphed it. So this is for the blue on for the X value. So as you can see, for the blue on and off, I should say, so it goes it's very similar. And for the white value, we go up here for the on, and then when we touch the off, it goes down. Now, when we see the green on and off and the white on and off, we see the same similar patterns. So let me get and explain one by one. So this is the panel, and when I did this, I went up and down like this, then stopped, and then went up and down here. So basically, this is for these two first. So I got the following. So this is the X value. Now, the X value for this blue on and blue off should be very similar, because we go from this point to this point and here to here. So, and it shows it comes from this value, the X, then I stopped and then started again, and you can see that this picture and this picture are fairly similar, and the values that I obtained for the X was between 648 and 788. That was the analog to digital conversion values from these two. They were fairly similar. Now, when it comes to the Y value, as you can see, I went here and they were very similar, the Y values between here and here. However, when you get down here, then the values also jump below, and that's what's expected, because you have Y here, your Y value here, and then the Y value down here. So that's what we got. And I went ahead and wrote the boundary values. So for the X is 648, 788. For the Y, it goes between 547 and 732. For the on, and for the off, it goes between 193 and 359 for these white values. So next, in my program, I have to evaluate. So I know if the value is between 648 for the X, 648 greater than 648 and less than 785, then I know I'm in this region. I'm in the blue. So now I have to figure out whether they press the on or the off. So here I go and say, hey, if the value is greater than 547, less than 732, that means it's the blue on. Now, if I'm down here, that means that the value is going to be greater than 193, but less than 359, then I'm in the blue off. So if I'm here, what I do is say I'm going to set a variable button value to 1. Then I'm going to send to the laptop I'm in blue on. If I'm in this area, then I'm going to set the button value to 2, and I'm going to send to the laptop the blue off for troubleshooting purpose if needed. So now, what do I do with these values, button val 1 and button val 2? Well, following this code, I'm going to have a switch. And if it's a case 1, then I know that the blue is on. So the first thing I ask is, hey, is the blue state off? Because what I want to avoid is from if it's on and it gets pushed a number of times and it's on, I'm going to ignore it. So if the value is not off, and when I set up my parameters, they initialize to off. So if the value is off, then what I'm going to do is I'm going to turn on the LED, which corresponds to the blue. I'm going to set the state to on, and then I'm going to send the information to the laptop. Now, if the value is 2, and the state of the LED is on, then what I'm going to do is I'm going to turn off the LED that corresponds to blue, and I'm going to set the LED state to off and send information to the laptop. Now, let me analyze the green. So when I looked at the green, was similar. The X area, they were similar value as expected, and the Y value, the on was between 536, 679, and the off was this value 165, 328. So if I'm in a X, if the X result from the analog to digital conversion is greater than 409 or less than 540, then I know I'm in the X value. I'm in somewhere between, I don't know which is whether I'm in off or on. So the next thing I have to figure out is I need to evaluate the on, which is greater than 536 and less than 679, in which case I'm on, and I'm going to set the button value to 3. Or I have to evaluate these two numbers that come from these parameters, in which case I'm going to set up to value to 4. Now again, with this, I have a switch statement, and if it's 3, then I know I need to turn on the LED green on, but first I have to make sure it hasn't been turned on before. If it's been turned off before, I ignore it. If it's off, then I turn it on and then send information to the laptop. If it's 4, then if it's item 4, then I make sure it's supposed to, I make sure if it's on. If it's on, then I'm going to turn it off. So, and finally, if I push the white, then again, the X values are similar, and what the values of Y are different. So at this point, if this is true, I know I'm in the white region, I could say, which is now I have to decide whether it's on or off. And then again, I do same as before. If it falls within this if statement is true, then I set the button value to 5. If it's within this range, the output from the analog digital conversion, then I set the value to 6. And then I have the switch statement, which if it's 5, if it's on, I make sure it's not on, make sure it's off, so I can turn it off. If he press off, then I have to, if it's off, I ignore it. If it's on, then I turn it off. So with this, I think I've given you a good idea how to analyze the buttons, and we can continue to with our presentation. Okay, so now let's go to sample program 2. So we had all the data. With that data, we have characterized the on and off each of the buttons. So let's go to sample program 2, where we're going to actually be turning things on and off. So step 1, capture the touch input. Write code that continuously check if the screen is being touched. When touched, read the X and Y position. That's step 1. Step 2, turn the LED on or off. Identify which button has been pressed and turn the LED on and off, turn on or off the designated LED. Transmit serially troubleshooting data for the raw X and Y parameters and the button select. So the main thing is to turn on and off these LEDs, but I also send data to the laptop, so if something goes wrong, we know what happened. So this is we're going to have the LED B0 green, port B1 blue, port B2 white. We read from here which button we get an input from the touch screen. We decipher it and see what action we need to take. So I'll first give you a high-level view of the program, and then we'll come back to look at the details. So we have a routine that is going to initialize the ports. This is so we can manage the LEDs that we're going to be turning on and off. Then we have the analog to digital conversion initialization, the initialization of the interrupts. Then we have here to enable and disable interrupts. Then here we enable channel 2, and here we enable channel 3 of the analog to digital conversion. This routine is going to configure so we can read the Y, and this is going to configure so we can read the X. And here we have the main program where we are just going to call whatever needs to be called to initialize the routines. Next, we have our interrupt service routine. This is where we're going to it gets called out every time there is some data available so it can process. So here's where we're going to process the X and Y parameters. We're going to evaluate those parameters, and we're going to decide which LED gets turned on or off. So let's get into the details. So here we have how we initialize the values, the port assignment for X1, Y1, X2, and Y2. Then some parameters for the on and off. The initialize ports, what we do is we set the port B0, port B1, and port B2 to output, and then we turn all the LEDs off. We do that so if for some reason the program gets interrupted, every time we come in back to the program, we make sure that things get initialized and all the LEDs are off. Here we initialize the analog to digital conversion. Now we've done that before, so we're not going to spend any time with this routine. Here we have a routine to initialize the interrupt, enable, disable interrupts. We've done that also in the past. The enabling the analog to digital channel 2 and channel 3, also we've done in the past. So in this case, what you need to do is go and review what I presented. Now here we have how to configure so we can read the Y parameter or the X parameter, and we've done that in the prior example. So it's just either X1, X2 or Y1 and Y2 get set to output or inputs, and then we assign ground 5 volts. Now let's look at the main program. So we initialize the analog to digital conversion, initialize the UART, initialize the port. There's nothing new here. We start by reading the X parameter and enabling the channel 2. We initialize our interrupts. Now we have some parameters here. We're going to initialize the parameter to not done. And why not done? That means that when we start, we haven't read any of the parameters. All the LEDs are off, and then we start with the hello world. So let's get into the interrupt service routine. That's where everything happens really. So as usual, we disable the interrupts, and then we're going to read the conversion results. So the fact that we're in this service routine, that means that there is some data available for us to process. So we load the data into conversion results. Now we also know which channel the data came from, and this is how we analyze the channel. And basically it can be channel 2, channel 3, and if it's neither of them, then we need to send a message. We may have a problem, and what we do, we enable the interrupts again if we keep going. So if it's channel 2, what we do is we save the conversion results in the parameter X, And then we have a variable says X read, and we put that equal to done. That means that the X has already been read and there is a parameter has been stored in the X variables. And then we send the Y to the laptop for troubleshooting, and then we enable the channel 3 of the analog to digital conversion. So the next time, as soon as we get out of this interface interrupt service routine, I should say, we go and get the Y parameter. When we get the Y parameter, next time we come back in, we save the Y parameter, and then we set the Y read to done, and then we configure so we read the X the next time and enable the analog to digital conversion so we can read the X channel 2. Now the next line that follows is here, and it basically asks, have we read the X and have we read the Y parameters? So we don't want to get to any of this what follows if we haven't read both parameters. So when we go in for the first time, we read the X, we get here, and that's how far we get, because then the interrupts get enabled and we're out of here. Now next time we come in, we read the Y, and then we say, hey, Y is done. So in that case, says is read X. Did we read the X? Yes. Did we read the Y parameter? Yes. So then we start this routine. The first thing is we reset the read X and read Y to not done. Next, the values that we had on the X and the Y, we store them into X val and Y val. Then we send these two parameters serially to the laptop for troubleshooting. Now at this point we have the X val and Y val, and that's when we start analyzing what button got pushed. So did the blue button did the blue on or blue off button got pushed or pressed? We'll know. We do this if statement. If this is true, then that means that either the X or the Y got pressed, and at this point we need to figure out which one did it. According to which one got pressed, as I showed before, we assign the button 1 or button 2. Now, if this is not true, then we check for whether or not the green was the one that green on, green off was the one that got pushed or pressed. And then if that's true, then we check if it was the on or the off on the green, and then we assign the 3 or 4 to the button value. And finally, we check to see if the white on and off was pressed. And if that's true, then we need to figure out whether it was the on or the off. And we already got the limits and how we got this done, as I explained priorly. Now, once we've assigned the value to the button, then we get into this switch statement. In this switch statement, we're going to have case 1 where the blue on was pressed, in which case we turn on the blue LED, and then we set the LED state to on, and then we send information to the laptop. Like I explained before, if the blue on gets pushed many times, it's going to go through. Once we're going to turn on, the rest it's not going to do anything, because the state has to be changed to off, and the only way to change that state to off is in case 2, where we turn off the LED and we turn back on. We turn off the LED and then we change the state to off. Now the same thing is going to happen with the green for on and off, and then we have the white on and off. In all these cases, what we do, if we have the on, we ask, hey, is the state off? Yeah, if it's off, then we turn it on. Now, if we press the on and the state is on, then we do nothing. We don't want to be pressing the on and on. So the same thing is for the off. If the state is off, then we don't do anything. It's off. You press it off and it's off. If it's on when the off has been pressed, then in that case, of course, we go and turn it off. Then this finally here we get to the breaks, and this is the end of this the interrupt service routine to end up with put a little delay to take care of some of the bouncing, and then we enable the interrupts and we are out of here. So let me see if I can recap. So first we figure out which button was pressed. That we solve these if statements. Then once we figure out which button was pressed, we go into the switch routine and we just do turn things on or then turn things off. So let's look at the output. So here you have the touch screen and the microcontroller and the connection. I had to put a little connection here because it comes with a ribbon. So let's look at the result. So here we're going to turn on the blue, turn it off. Then we're going to turn on the green. Then we're going to turn it off. Then we're going to turn on the white, and then we're going to turn it off. Now we turn on the blue, green, and white, and then we turn them off each at a time. So this gives you an idea of what the program is doing and how pressing this touch screen that I created and how we figure out. I just took a piece of paper and drew the squares, and then how the process we went through to make sure that we can make that work the way we want it. And let me show you this one more time. So we just press the glass and things happen as we program them. Okay, so we can continue with the presentation. Okay, so let's, what we have left now is the summary. So today what we did is I talked about I gave you a touch display, I gave you a description. Then we show you how things get wired, schematics. Then we went to sample program 1 where we got all the data required to we could make things function. Next, we went sample program 2 where we actually made the touch panel do something. So anyhow, I hope you've enjoyed this presentation. Thank you for taking the time, spending time with me, and hopefully I'll see you again. And thank you again.